Probability, per the definition, is simple probability consists of one event happening at one location, I guess. It is calculated by dividing the number of outcomes over the number of possible outcomes. Probability can be given as a fraction, decimal, or percent. Most of the time in class, I'm just going to put it as a fraction. You can change it to a percent if that makes more sense to you. But fractions are just easy to work with, and we're already working with them. All right. Let's do example 1. It says Bobby who?
Murder.
Oh, yeah, that's the guy I was thinking of. Bobby rolls a 6-sided die. What is the probability P that he will roll a 2, which is probability 2? So when we're talking about probabilities, we're going to use a cap P. Cap P, and whatever's after it, it's saying probability of that happening. So if we look at this P2 is probability of rolling a 2. So in fact, what I'd put on the outside of this is we'd have probability of rolling a 2 is going to equal number of, basically I look at it as being successes over how many could happen. So if I'm going to roll a 2, how many opportunities are there to roll a 2 with a 6-sided die? How many 2s are there? Yeah,
1.
There's 1. So your number of you actually possibly getting it, there's just 1 on that die. There's only 1 opportunity on that die for you to roll a 2. However, there's a total of 6 sides to the die. So our number, we have 1 basically that works, and we have 6 total. So our probability is going to be 1 outcome over 6 possible, or just putting 1 over 6. Like I said, you could write that as a percentage, which is like 16.7%. You could write it as a decimal, but we're just going to leave it as a fraction. It just makes things easier. But if you love percents, I'm not going to take points off. But that's it. That is probability. You look at how many of them you could win with, and then how many out of your total. So our next problem says, example 2, find the probability of observing a number larger than 4 when rolling a single die. How many numbers on a die are larger than 4? Make sure you're not including 4. Yeah,
2.
There's just 2 of them. There is 5 and there is 6. So there's 2 that are larger than 4. That would be 5 and 6. So we have 2 possible outcomes. We have 2 possible outcomes over 6. We have 2 outcomes that work and 6 possible. So our probability of getting larger than a 4 is going to be 2 over 6, which equals 1 over 3. The next one says, find the probability of observing a sum of 5 when a pair of dice is rolled. So this time some of these you have to look back at what would actually add up to 5. Normally I wouldn't write all of them out. I would just think in my head, okay, we have 1 and 4. We have 2 and 3. But be aware that you can flip the dice. So I can roll a 1 and then a 4. And I can also roll a 4, then a 1. Those are 2 different outcomes. I could roll a 3, then a 2. And then I can roll a 2 and then a 3, which would be 2 also outcomes. Otherwise, we can actually list them all out and count all the ones that equal 5. So we have a 3 plus 2, a 2 plus 3, a 4 plus 1, and a 1 plus 4. Like I said, it's much more efficient just to count in your head. But a 4 and a 1 and 4 are 2 different outcomes. Be aware of that. So there are 4 outcomes that equal 5. So the probability where we have a sum of 5 is going to equal 4 out of, and how many numbers are on there? Yeah. Yeah, how many of these are there?
36.
36. Did you actually count them?
No.
What'd you do?
I just saw there were 6 rows and 6 columns.
Yeah, 6 times 6. Your first row, you have 6 possibilities. Your second row, you have 6 possibilities. It's just 6 times 6 would be our total outcome. So there are 6 times 6 of these, which equals 36. We would go ahead and simplify it. 2 over 18 or 1 over 9. Probability of having a sum of 5. Number 4. Find the probability that you will roll a 6 and then a 5 when you roll a die twice. So we're going to do the probability of where I roll a 6 and then I roll a 5. We're going to find a different way to do this. But let's just look on here. How many on there have an outcome where your very first roll is 6 and then your second one is a 5? Liv? 1. There's just 1. How many times can you roll a 5 and then a 4? 1. How many chances are there to roll a 2 and then a 3? 1. They're actually this is actually telling you your 2 die. It's saying you roll a 6 and then you have to roll a 5. There's only one of those outcomes on there. So there's only one. So the probability of rolling a 6, then a 5, is there's just one of those up there. It's a 6 and a 5. So that's 1 over 36. All right, that in a nutshell is simple probability. You just see how many there are over how many possible you have. Now we're going to get to something called compound probability. That is when 2 things are happening. It is when you have 2 things happening, there's 2 kinds. There is independent and then there is dependent probability. Independent, like it sounds, both events are independent of each other. Dependent means one is dependent on the other. So let's go through both of those. So the first one is probability of independent events. That is the outcome of the first event has no effect on the outcome of the second event. Now, this is some notation. Remember, P is probability. This is saying the probability of A and B happening. This little upside down U stands for and. What is the probability of this happening and this happening as well? That's all this is saying. Well, if it's independent, you're just going to take the probability of your first event and multiply it by your second event. My example there is rolling a 6 on a die and then rolling a 5. You rolling a 6 has no impact on your next roll. As much as Vegas wants you to believe it does, they have like, if you ever have seen like videos, they have roulette tables and they actually say what numbers were picked before because then people bet on numbers that haven't been picked yet. What happens before has no impact on what happens next. I can roll 6 sixes in a row and I still have the same probability of rolling a 6 next time. All right, your previous rolls have no effect on your next rolls. So rolling a 6 and then a 5 have no effect on each other. So that is an independent action. So in fact, if I was to calculate this, that would be the chance of rolling a 6 on your first die would be 1 over 6. The chance of rolling a 5 would be 1 over 6. So your answer to that one would be 1 over 6 times 1 over 6, which would be 1 over 36. All right, let's go on to dependent. Dependent is when your first event does affect the outcome of your second event. And that is probability of A and B happening will equal probability of A times probability of B being affected by probability of A, which would make more sense when we do this example. So it says, without replacing the first card, choosing an ace and then a king from a deck of cards. So I have a deck of cards and I pull out an ace. I hold on to that ace. You now have less cards in your deck for me to pull from. So my pulling an ace actually affected how many cards are still there. So in this case, if I was calculating the probability of this one, the probability of pulling an ace from a deck of cards is a 1 in 52 chance. There are 52 cards. Saying we don't have the instruction card in, we don't have our jokers in. We have 52 cards. There's one ace, and I'm going to pull that out of the deck. I'm not replacing it. So now what's in your hand is now 51 cards. Well, to pull a king out of that would be 1 over 51. My odds are slightly better because there's less cards. All right, so with independent, you're multiplying by the same thing. It's not affected by the first one. With dependent, you have to ask yourself, does that first thing affect my second probability? Let's go through some examples. So find the probability that you will roll a 6 and then a 5 when you roll the die. Well, we did that above. We said the probability of rolling a 6 is going to be 1 over 6. Then we said the probability of rolling a 5 is just 1 over 6. So they're both the same because this is independent of each other. So we're just going to multiply those two things together to give us the probability of rolling so this is the probability of rolling a 6 and a 5. Upside down U is and. Is going to equal 1 over 36. You just multiply them together as long as they're independent. All right, our second one says we have a bag containing 3 marbles. 3 red marbles, 2 green marbles, and 4 blue marbles. 2 marbles are to be drawn randomly from the bag and not replaced. Find the probability of both marbles are blue. So we're pulling out a marble. We're not replacing it. We're just setting off to the side. And we're grabbing another marble, setting off to the side. What's the probability of both of them being blue? Well, since I'm not replacing it, me pulling out that first marble makes the bag lighter, right? We have less marbles in the bag. So that means it is, in fact, dependent. This is dependent because my first action affects my second action. So it's dependent. And so let's go ahead and talk about the first marble. Probability of basically our first marble being blue. So that's going to be our first marble. What's the probability of my first marble being blue? Does anyone take a shot at that? What's the probability of me sticking a hand in the bag and getting a blue one out? Yes. 1 in 9 chance. What did you start off with, though?
What do you mean? What did I start off with?
Yeah, so our first one is blue, so you just went to 1 in 9 chance?
Yeah, because you're only drawing 1 marble, and there's 9 marbles. So
How many blue marbles are there, though?
4. But you're just drawing a marble randomly.
Mm-hmm. What are the chances is blue?
Uh,
It is affected
4
by
in
how
9
many you have.
chance.
It'd be 4 over, yep. It would be 4 over 9 because you have 4 blue marbles that you could possibly pull, and there's a total of 9. So basically I have 4 would be success out of 9 in the bag. All right, that is my first marble is 4 over 9. Now let's talk about our second. Our second marble is also the probability of pulling a blue. What is the probability that the next one is blue, knowing that I grabbed one, set it off to the side? Think about how many blue marbles you have left, and think about how many are left in the bag. What is our probability? Yeah. 3 over 8. Yep. It would be 3 over 8. Because we have 1 less blue marble, and we have 1 less total marbles. I pulled 1 blue out. So this one is dependent on, hey, the first one was a success. We're saying the first one has to be a success for my second one to work. So if this one was successful, I pulled out a blue marble. I have 1 less blue marble. I have 1 less marble. So it'd be 3 over 8. Now we just need to multiply those together. And that's going to equal 12 over 72, which we can simplify down to, 12 goes into 72. Yeah, right? Yeah. 6 times. Remember, I don't write all the notes you need to. I say things, right? I would probably have a lot more notes on there saying how I got that 3 and 8. That'd be my personal thing if I was taking notes. All right, the very last one. The very last one is a couple have just given birth to a baby girl. What is the probability that their next 2 children will also be girls? Is that dependent or independent? Yes? Independent. If you have a girl, you still have we'll say about a 50-50 shot at having a girl the next time. You have 50-50 shot the next time. Either it's a boy or a girl. So it is, even though it's set up to look like it's not independent, it is in fact independent. Since it's independent, do we even care that their first kid was a girl? Does it affect the next one at all? No. So we're just going to go to the probability of your second is a girl. Like I said, it's 50-50. You have a 1 in 2 chance of your second child being a girl. And then we do a probability that your third child is a girl. Once again, that's 50-50, so it's 1/2. You just multiply those two things together to go. You now have a 1 in 4 chance to have all girls if your first one was, in fact, a girl. If the first child was a boy, what are the chances that all their kids are girls? If the first one's a boy, what are the chances that all their kids are girls? 0. They already had a boy. All right, but that's probability. That's simple probability and a little bit of compound probability. All right, the rest of the time is for